Hello everyone, my name is Fatma Nazira. I am from Said Ali Rahmatullah State Islamic University. And in this video, I will to explain my science project for the final International Wali Songo Science Competition. Okay guys, you know what this toys? Yes, this is a slingshot. Slingshot are one of the traditional Indonesian toys that went viral in the 90s. In ancient time, slingshot were used as a tool of war during the independence era. However, over time, the function of the slingshot has changed into a traditional game, which is usually used as a toy by children to hunt small animals or simply as a war toy for children. And in the modern era, slingshot has been transformed and we can play it on mobile. And you know what is game? This is one of the games that went viral in 2010. Play by throwing bird with a slingshot. This game reminds me of the spring principle in everyday life. So, in this video, we will learn about the basics of slingshot. Let's learn with me! The tools and material in this experiment, the first we have a rubber, the second we have a masking tape, and the third we have a clip paper. First, prepare the rubber band that we will use. Then, cut the rubber as a ball. Prepare the tape and glue the rubber as in the video. The system is ready to try. First, when we pull the rubber parallel to the x-axis with a certain amount of force, the rubber will stretch and create potential energy due to the pulling load that we apply. Potential energy will change to kinetic energy when the throwing base is realized. This is due to the transfer of energy between the rubber slingshot and the wheel that is realized. The potential energy product is elastic potential energy. Elastic potential energy is potential energy stored as a result of the formation of an elastic object, such as the stretching of a spring. It is equals to the work done to stretch on the spring, which dependent upon the spring constant k, as well as the distance stretched according to Hooke's law. The force required to stretch the spring will be directly proportional to the amount of stretch. So, in this experiment, we have two experiments. The first experiment, we use one piece of rubbers, and the second experiment, we use two pieces of rubbers. The greater the spring constant given, the greater the force received by the object. If we use one rubbers, then the throw will be shorter than a system with two rubbers. This is because the spring constant will be directly proportional to the force product. So, in this system, we have four constraints. x1 equals x2 equals x, y1 equals y2 equals min y, l1 equals l2 equals l, and k1 equals k2 equals k. This system is moved in one dimension. It has only 1 degree of freedom, because there's only move in x-axis. To find the equation of the system, we can use the Euler-Lagrange equation. The Euler-Lagrange is generally shown by equation 1. Lagrange of the system, the kinetic component indicated by T, and the kinetic energy indicated by V. The statement shown by equation 2. For the T, we can use the kinetic component T equals half mass x dot square. For the V, we can use the kinetic energy V equals KL square. We can substitute the equation 3 and 4 into equation 2 and get L in equation 5. With the equation of the x-axis, the mathematical solution is shown in equals 6. And we can substitute two Lagrange equation. To get the equation of y-axis, the mathematical solution is shown in equation 7. So we can substitute the equation 7 to the Lagrange equation. So in this equation, we get the object only move on the x-axis. With the equation and the y-axis, the object does not move. So physics is fun, right? See you!